I'm going to just move quickly to explain these exponent plots, because I'm sure that you guys probably don't remember them. So what happens when I have x cubed times x to the power of 4? X to the power of 7. That's right. That's right. X to the power of 7. How do you get this? Add the exponent. Excellent. So why is that? Why am I using two bases? Now the important part is they have the same base. You see that base right here? The x is the same base, right? So technically this is what it means. X cubed. If I want to expand it, what does that mean? What's x cubed mean? Explain it to me. Exactly. It's x times x times x. That's what x cubed means, right? So technically this means x times x times x. Okay? These are x's. I should have chosen a better letter. Okay. Now they're also multiplied by x times x times x times x. So if you look at this, I have 7 x's multiplied together. So that simplifies to x to the power of 7, right? Instead of writing x 7 times. Take whatever. Now, this is where they came up with the rule that we call the product rule. Okay? So if you have the same base, right? If you have exponentials that have the same base and you're multiplying them, what you do, you add the exponent. So this is how you simplify. Okay? So if I have, the rule is a to the power of m times a to the power of n is equal to a to the power of m plus n. Now the same goes for, well, similar things, goes to the quotient rule. Quotient rule means division.
So a equals a m plus n?
That's right, a to the power of m plus n.
So what are you doing? You're just joining them together?
I'm just adding the exponents, yes. Now, what happens if I have, I'm going to choose a better letter here, if I have a 5 over a squared.
5 take away 2.
5 take away 2, that's right, that's right. Let's explain why. Let's look at why is that. So a to the power of 5 is actually a times a times a times a times a 5 times. Divided by a squared. So that's a times a, correct? So when it comes to simplifying, when you're dividing, what you simplify, you just get it over, right? Because if you divide 1 by 1, it's going to give you 1. So they're going to cancel. This is going to go with this. This is going to go with this. So what am I going to end up with? With a cubed. Right? So the rule says if you're dividing, you have the same base, you're dividing two exponents with the same base, you're going to subtract your exponents. Okay? So that says a to the power of m over a to the power of n is equal to a m minus n. Okay? So these rules are going to be very, very useful for the next few questions.
So how would you know if it was plus n or subtract n?
If you're multiplying, you add the exponent. If you're dividing, you subtract the exponent. Okay? So let's go back up. So let's look at this question. 4x squared y times 3x y to the power of 4 times z. What am I doing here? Multiply. Okay? When you see two brackets like this, right? When you see this, that means you're multiplying, okay? So let's look at, what do I do? 4, what do I multiply 4 by? 3. You always multiply the numbers together, okay? They're called coefficients. So 4 times 3 is 12. Now, x squared is multiplied. You always have to take the same base. Remember, I've told you that so many times. It has to be the same base. Otherwise, you can't just do it. So I have x squared times x. What do I get? X cubed. Yeah, it's x3, right? And the reason for that is 2 plus 1 is 3.
Hold on. So
Yes.
x squared plus
Times.
3x.
Forget about the 3. 3 and 4, I multiply them together.
Yes.
Gave me 12. Then I move to the x. I have an x squared times an x. Okay?
So you add
X
the
squared times the x.
Oh, so you add.
You add the exponent. 2 plus 1 is 3. Right? Anything that doesn't have a number on top of it, it's a 1. Are we okay so far?
Yeah.
Okay. After the x, I have the y. Y times y4 is y to the power 5. And then z, there's no other z, so I would just write it as this. Okay? So you see how I'm moving step by step, little by little, letter by letter. Okay?
So we added exponents together.
That's correct. They have to have the same base though. Can I say that more?
Yeah.
They have to have the same base.
Yeah.
So you can't just, say, oh, I'm gonna add all these exponents together, because that's not right. Okay? They have to have the same base. Okay. Are we okay with this?
Yes.
Can I move on? Excellent. So next one is 16xy squared divided by 8y. Okay? I personally prefer to look at it as this instead of this. I prefer to look at them like this. Okay? It looks neat. Okay. So always you divide the numbers by the numbers. Okay? So 16 divided by 8 gives me 2. So I'm done with the numbers. X. Do I have any other x?
No.
No. So I have to write it. Nothing happens to me. Y squared divided by y. What do I get? Y. Why do I get a y? Subtract. 2 take away 1 is 1. Done. Okay, what I'm going to do right now is I'm going to set up the next question for you.
I have one thing in my mind at present, no.
Sorry? Yeah.
It was my bad luck. I couldn't get teacher. In 1963, when I was in 900, I couldn't get teacher like you. Who was explaining like this.
Thank
That's why
you.
you should learn algebra, At 71, you have to learn algebra.
Thank you.
So what do we? There was no x there, so we just automatically bring x down.
You automatically write it as is because there's nothing to simplify with it. Okay, so I'm going to set up the next question for you. We're going to explain why we're going to set it up this way, and then I'm going to let you do it to see if you guys can do exponent law. Now, when you have a polynomial, so this is a polynomial, right? Trinomial if you want. 9x cubed y squared plus 18xy minus 6x squared y cubed divided by 3xy. That means every term
Here, divided by 3.
is divided by 3xy. Okay? So this is the same thing as writing this. Right? Because every term is divided by that 3xy. Now, use the rules that we just used in the previous question to simplify this formula.